Hello and welcome to another session in further mathematics. Today we'll be discussing on the topic calculus. But before that, let us review our previous lesson. Okay, welcome back. Now, when we talk about calculus, series of things usually come into our mind. I think the first part is called differentiation. The other part is called integration. Now, when you talk about differentiation and integration, you're just talking about rate of change and rate of increase at a given point in time. So I would like us to go straight into dealing with differentiation. And when you talk about differentiation, we have certain rules that binds differentiation, and without your knowledge about these rules, you'll not be able to ascertain the rightful evaluations that we have in differentiation. The first rule here, from what we can see in front of us, is dc all over ds equals 0. Now, let me go further into explaining this rule. This rule tries to tell us that when you have a constant term in differentiation, after finding the y, the x of the constant term, the answer is usually a 0. Like, for example, if I should tell you to find the y, the x of 4. Now, the y, the x of 4 is 0 because the y 4 is a constant term. If I should still proceed ahead in telling you to look for the y, the x of 5, 6, 7, 8, 9, and 10, so on, even your answer is still 0. So, in differentiation, you have to understand that whenever you differentiate a constant term, your answer will definitely be 0. That is the first rule we have here. Now, the second part, we did this in our previous lesson, trying to prove the law that governs differentiation. We said when you differentiate x raised to any given power, then you go by this rule. You now have, if you find the y, the x of x raised to power n, you now have n x raised to power n minus 1. So this rule can be justified by, if you differentiate 5 x raised to power 5. Now let's say 5 is our n term, so we now have 5, now bringing the n back, 5 x raised to power 5 minus 1, which is 5x raised to power 4. So if I should give you 5 x raised to power 5 to find the dy dx of it, you definitely come out with a result 5x raised to the power 4. It's so also applicable in other functions of x. Now, when you talk about the product rule talks about finding dy dx of two different quantities or elements that are related using multiplication. For example, I can tell you to find the dy dx of x plus 5 and e raised to power x. So in this context, you make use of the product rule. So if this is d dx of fx of g, let's take x plus 5 to be in fx and e raised to power x to be in gx. So if you want to get the dy dx of this function, you bring down x plus 5, look for dy dx of ex plus you bring down ex and look for dy dx of x plus 5. As we proceed further, we'll go into solving questions that has to do with the product rule. Now, since product rule have to do with multiplication, quotient rule also involves division. Now it talks about finding the dy dx of fractions, and at this point we have the denominator and the numerator. So when you have numerators like x squared plus 3 over e raised to power x plus cos theta plus cos x. So when you have e raised to power x plus cos x, if you want to look for dy dx of this type of function, what you have to do is to apply the quotient rule. and if you apply a quotient rule, you know that you have g of x f(x prime) raised to x minus f in bracket x, and the differential quotient of x all over gx square. So the last here is chain rule, and when you talk about chain rule, I think we did chain rule in our previous lesson as well. I told you that chain rule talks about the interrelationship between three different variables whereby they are not directly related, except there is a relationship between the first and the second, or the second and the third, and that relationship can serve as a basis in connecting other variables to this. Now I would like us to go into detailed solving and proving of the this thing. Now let's say rule. Let's create the first one that says functions of two variables, that is addition of differential functions. So let's say let's u and v be a function of x, a function of x. Now when you have a function of this nature, that is to say we have y equals to u plus v. Now this, if you want to find the dy dx of a function of this nature, you have to find du dx plus dv dx. So you differentiate this with respect to x, and you also differentiate this with respect to s. Then when you're done, you add them. Then with that, you get your differential result. But one of the things I want us to understand, remember I said, we proved in our last class that every differentiation works on the principle of if x raised to power n, then dy dx is equals nx raised to power n minus 1. So I want us to apply this by solving. This should be our first question, question 1. Find dy dx of 2x cubed minus 5x3 5x cubed plus 2. Now in this, remember here the value of our n is 3, and here the value of our n is 3 as well. So you now say dy dx is equals, you have 2, now bringing back this 3 being our n, times 3 raised to power x 3 minus 1 minus, this is 5, then our n at this point is also 3, you bring it back, times 3 raised to power x 3 minus 1 plus 2. And you know, when you have a constant term, we stated it in our previous points before now, that when you differentiate a constant, you have 0. So at this point, plus 0. So this becomes 2 times 3 is 6, and x raised to power 3 minus 1 is x squared, minus 3 times 5 is 15, then x raised to power 3 minus 1 is x squared. So 6x squared minus 15x squared will give us minus 9x squared. So the dy dx of our equation is equals minus, so we write it dy dx is equal minus 9x squared. I'd like us to also try solving another question to increase our level of familiarity with this context. So we now have 3x4 plus 2x cubed minus x squared plus 1. Remember, each time you see a constant term, when you're looking for the differential coefficient, I said it equals 0. So with this, we have dy dx as, remember the rule is if x raised to power n, then the dy dx is n x raised to power n minus 1. So always learn how to apply it. So at this point, our n is 4. So it's 3 times 4, x raised to power 4 minus 1 plus, at this point our n is 3, so we now have 2 times 3 x to the power 3 minus 1 minus, we now have 2, our n at this point is 2, so we now have 2 x to the power 2 minus 1. Then when you have 1 being a constant term is plus 0. So we go further into analyzing. 3 times 4 is 12, x to the power 4 minus 1 is 3, plus 2 times 3 is 6, x to the power 3 minus 1 is x squared, minus 2x 2 minus 1 is 1, so you leave it like this. So the dy dx of this function is equals to x cubed plus 6x squared minus 2x. So to refresh your memory on what we've just discussed, take the test on the screen. Do well to always use this lesson note on the platform for a better information on the topic we've discussed. Always feel free to drop your comments, your questions on the comment section. We'll be glad to hear from you. Thank you. See you in our next section.